Hi, everyone. Welcome to You Got a QIF File. Now what? I'm your moderator, Jimmy Nguyen. Some housekeeping rules. If you have questions, please enter them into the chat. We're here for about 30 minutes of content and then 15 to 20 minutes of Q&A. Let's meet our presenters. Our first presenter is Shannon Litwin, an account manager at Capvidia. With nearly a decade in design engineering across aerospace and defense, Shannon has designed primary structures, partnered with technicians on the shop floor, and worn both engineer and technician hats, aka Wizard, at startups. This all hands-on-deck approach is why people trust and rely on her. Our second presenter is Alex Kulik, an enterprise account manager at Capvidia. Alex brings 10 plus years in quality with a strong focus on metrology and supplier quality leadership. He's led technical teams through big changes, using digital tools to drive real measurable improvements so that people can spend their time where it matters most likely more meetings. That's it for introductions. Let's begin. Shannon, it's all yours.
All right, thank you. Many of you already know Capvidia, but for those who don't, here's a little background on us. At Capvidia, we give OEMs and their suppliers the tools to automate data exchange, cut costs, and create a fully traceable digital record, one that can feed your AI tools, support compliance audits, and uncover hidden performance trends across your supply base. We have just over 30 years in manufacturing digital transformation, in CAD translation, validation, and model-based definition, which is what Alex will talk more about in just a minute. With our MBD solutions, we're not just redefining manufacturing workflows, but we're building connected, intelligent ecosystems for both OEMs and suppliers. Next slide. So we decided to host this webinar for a couple of reasons. The first is that there's a good chance your company or a company you work with already uses our software for their model-based engineering. We have OEM and supplier customers in aerospace and defense, medical devices, and automotive, so we're a trusted software and service provider in the MBD space. The second reason is that we've seen a recent shift in the OEMs from using model-based engineering for internal digital transformation, and now they're starting to push that transformation through their supply chains and expecting model-based practices from suppliers as well. Alex, it's all yours.
Thanks, Shannon. Okay, so you got a QIF file. Now what? Your first thought might be, what is this? There's nothing like a new file you can't open when you've already got a PO and a delivery date from your customer. So what is a QIF file? Why is your customer sending this to you now? And to begin with, how do you open it? So think of a QIF file or quality information framework like a neutral CAD file, similar to STEP. It's based on an ISO standard that's designed to be a single machine-readable source of truth for a part or assembly. QIF is much more than that and can do many other things, but we'll save that deep dive for a future session. You can think of QIF as a container for a lot of the information that's previously been kept in many other different formats. It contains visual part geometry, dimensions, tolerances, fabrication and measurement requirements, as well as inspection results. And it was created specifically to ease communication between suppliers and their customers. For now, we're going to focus on the question, why did you get a QIF file? Simplest answer to that question is model-based definition, or MBD. To sum up MBD, when we say MBD, we're talking everything in the 2D drawing, dimensions, tolerances, notes, all of that is now in the 3D CAD model as the single source of all relevant product and manufacturing information, or we refer to that as PMI. Our focus with QIF specifically is machine-readable PMI. What we mean when we say machine-readable is that you're not relying on a human to interpret the meaning of the requirements. So we're no longer relying on people to accurately duplicate design information that already exists when we get to the next step in our manufacturing process. Instead, we're transferring that information correctly and automatically using the QIF file. The point of MBD, QIF, and all of these other Industry 4.0 buzzwords is really to enable automation downstream and reduce or even eliminate manual interpretation, the need for intervention, and the errors that come with those things. For example, ballooning hundreds of annotations on a part or assembly can take hours or even days to do it manually, and often results in misrepresentations or misinterpretations. And machine readable PMI is the start of a true MBD journey. DoD mandates kickstarted MBD, and as a result of that, it's starting to cascade across manufacturing. Major OEMs like Lockheed Martin and others now publish supplier playbooks that outline their model-based enterprise strategies, and that includes model-based definition. And broadly speaking, that's why a QIF file just landed in your inbox from an OEM or a tier 1 or 2 supplier. And this is where Capvidia can help you. So why does QIF and being MBD ready matter to suppliers and to supply chains more broadly? First is consistency. All the information you need is in one spot. Customers and suppliers are working from exactly the same file. Second, automation in measurement programming and reporting. You can use the same authority file to transfer quality information to your CMM software, and then take those measurement results directly back to that same authority file. Overall, this results in simplified workflows and ultimately cost reductions. There are fewer items to keep track of. You have reduced CMM programming time, and requirements are unambiguous and machine readable, all of which reduces the risk of rework. Our main message from Capvidia that we want to convey is that QIF and MBD are a win for both large OEM customers and their suppliers. Working with a single file provided by your customer that includes all of the information needed to manufacture the product will allow you to communicate more clearly with your customers, and most importantly, get quotes and product out the door faster. The best part of this is that you don't need much to get started. A license of our primary product, MBDVidia, lets you view a QIF file, export inspection reports, share browser viewable files, and do all of that within minutes of loading the software. A point we really want to drive home is that there are easy wins that you can pick up right away, and they're all compatible with your current quoting and production processes. I'll hand it back to Shannon now.
Okay, so with MBDVidia, like Alex was saying, it's really something you can get using on day one, and you can start by quickly opening a QIF file, dragging and dropping the file into our software program. MBDVidia is an MBD workflow software for automating processes like quality inspection reports. It does both 3D files, so QIF files like we've been talking about, but it also does step files, including the newest version like step 242. And it also does 2D PDF drawings for your customers who still send you those. So let's do a quick walkthrough of MBDVidia. Today I'm going to walk you through the basics of a QIF file, what it is and what you can do with it using the MBDVidia platform. So the three major things you can do with a QIF file, just before I open it up, in this environment is you can inspect it and all of its features, you can export its data to various formats, and then you can also import the results back into this platform. So let's get into the specifics of that. You can drag and drop a file into the environment, but my preference is going to the Open button, clicking my file, and then clicking Open. And now you can see I have my QIF file, and down in this information, it will tell me what file it opened. And then on the left-hand side here, we have something called a model tree. This has a lot of information that is very useful, some of which are the features. These will go over the primary structural aspects, so planes, points, arcs, depending on how you have things defined in your original CAD model, that will change what shows up here. Another thing that is very important are these annotations. So if I click on characteristics, that highlights pretty much everything. If I want to go through each of these characteristics one by one, I can select each one, and this can be used for reviewing or for running various checks that you might want to do later. Now, all of these characteristics are what's called semantic annotation. Semantic annotation means it's not just human readable. You can also load it into an appropriate computer program like a CMM machine. We'll get to that later, and it will understand what these notations mean. Another thing that I'll touch on very briefly are these saved views. Now, these views are akin to what you would find in a 2D drawing, and I'll go more into those in a little bit. Now let's move on to the bill of characteristics. Similar to if you had a two-dimensional drawing, each of these dimensions and each of these GD&T designations needs to be given a balloon number so that after fabrication is complete, you can go through each of those items and make sure everything is in spec. So the easiest way to assign balloon numbers to all of these items is to go up to this bill of characteristics, click the button, and you can see that has automatically added a balloon number alongside each of these items. Each measurement gets its own balloon, and then each GD&T marker gets its own balloon. And then it's also made the bill of characteristics visible. I'm going to change my preset to make it a little easier to look at. And this bill of characteristics has everything that you need to manufacture this part. It's called Product Manufacturing Information, or PMI for short. Among the things that it has what view a particular characteristic is saved to. It has a feature name, an annotation name, which ties back to the annotations I showed you over in the model tree. It has the nominal value for any of the characteristics with the tolerance alongside it, and any GD&T that is applicable. It also has criticality, and if a measurement device is specified by the OEM, that will show up here as well. Something that is really cool to note, if I zoom in here and click on this characteristic, it highlights it for me here in this bill of characteristic, and then I can do the reverse. Click on something in the bill of characteristics, it highlights it out in my visual space so that I don't have to go hunting for anything. And now there are a few tabs down here. This bill of characteristics is split up into a main tab, which is your basic measurables, your non-measurables, which are going to be things like pass-fail items, and then any datums. And we also have the possibility of adding more tabs just depending on what information your QIF contains. So for instance, if there were any notes in this, or if there were any welds, a notes tab and a welds tab would be added down here. Let me go back to the main tab, and there's one other thing I want to show you. So one thing that makes a bill of characteristics different from anything you could create by hand is something called a UUID. Now, this UUID is a completely unique identifier for every characteristic, and the bill of characteristics has its own UUID as well. These UUIDs make sure that basically across all time and space, no matter what program you're opening this in, these UUIDs will carry over, and this bill of characteristics can be matched to its version in any other program, and so can each of these characteristics. Now that we have our bill of characteristics, there's a few things that you can do with it. The first you can do is export to an inspection report. There are a couple standard templates to choose from. If you're in aerospace or aviation, you'll be familiar with this AS9102 form. We also have a welding report, an ISIR form, which is good if you have multiple serial numbers that you want to check all in one place. And then you can also add a customized form if the company you work for has a special form that they like to use internally. So before I export, there's just a couple things I want to point out. We have this main tab, the non-measurable tab, and the datums tab. And you'll notice in this main tab, all of these checkboxes are blue, and the non-measurable tab, all of these check marks are blank. Now, what this means is these blue checkmark items, those will be exported, whereas these items will not. If I want to export them, I can select which ones I want exported. I can select an entire category, but I don't really care about the non-measurables right now. So I'm just going to click the export button. I have a couple file types I can choose from. I like this one, so I'm going to export that. And it did check to see that I had a file by this name already. That's okay. I'm just going to replace it. As you can see down in the lower left, we have a progress bar, and that will show you the progress as it exports to an Excel. You can see now that it's finished because it's given me a message that it's done so. And so now I can go to where I've saved that, open the Excel, and now I have a good bit of information to look over. So the first page on this AS9102 form is just your basic part information, like its name and any of the assembly items that went into it. Page 2 is going to be your material information, and then Form 3 is going to be each of those characteristics that was ballooned before. And so you have the balloon number here in this leftmost column, and you'll notice that it has a link. So if I click that, that will take me to the view where that characteristic is found. And if I tab through each of these, I have view 1, view 2, view 3. And I said I would explain these saved views before, so the saved views in that Excel correspond to view 1, view 2, and view 3 that I have here in this model tree. In addition to generating an Excel report, you can also generate a 3D HTML report, which you can do by clicking this button here. Save it. Now, the HTML report is really good to have in addition to the Excel report. So you can see that generated pretty quickly. Pull it over from my other screen. And this is interactive. So you can see it has all of the characteristics that the VOC had. And it also has the same views. So I can go to the default view, view 1, and then just like the VOC and MBDVidia, I can click a characteristic and it will make it highlighted down in this list. And I can do the reverse as well, bring that into view. This is really good for working on the shop floor. Say if you have a computer that you want to pull up the QIF file while you're running the inspection. It's also good to send around to other people who might need it, like procurement, if there are various parts that need to be bought that are a part of this subassembly. And none of them will need to have an MBDVidia license to view the HTML report. And so that can be opened in any browser, including on a tablet or phone. Now that you have your reports, you're ready to machine your part. Now, a lot of times in the technical data package that the OEMs send you, that will contain a QIF file and a step file. But in the event that it does not contain a step file, you can go to the Save As button, select File Type as Step, Save, and then if you want to check on the step file you just created, you can open that here in MBDVidia as well. So you see here we have the step file. It looks exactly like the QIF file you just had. That is because MBDVidia will automatically select step 242, which will hold PMI information very similar to the way a QIF does. Now, if your CAM machine cannot process step 242, you can export to a different step format. You would just have to change that in settings. Now, the big advantage of a QIF file is that once you've completed fabrication and you've performed your inspection, you can import results back into the QIF file using MBDVidia. You do that by clicking the Import button, selecting your results file, which is just going to be the Excel file that you filled out earlier, and that will use the UUIDs that we mentioned before to make sure the results are paired with the correct characteristics. So as you can see, it created a results file from the file, or it created a results column from the file that you imported. And that's one way of getting results into MBDVidia. Another way of importing results is if you use a CMM program like Calypso or PCDMIS. If you do inspection that way, you can use a QIF file to program the inspection, assuming that the software package you have is recent enough. Once you have those results, go to the Insert. You would select whatever results file you have. Since I don't have one, I'm just going to select Out. But if you did have a results file to import, that would also create a column. Now, as you've noticed, there's different colors that these results show up as. Green means you're well within spec. Yellow means you're technically within spec, but you're getting a little farther away from nominal than you might like. And red means totally out of spec, not good. We also have visual representations of these results. I'm just going to use the thermometers. And the thermometer is going to show your nominal in the middle, surrounded by a green section. Yellow is when you're getting close to where you don't want to be, and red is outside of tolerance. I can go through and click on any of these. Let's find a green one. And so that one, the nominal, is over on the left-hand side because there is no tolerance on one side. There's only tolerance on the plus side, not the minus side. The other thing you can do within the MBDVidia environment, we have a partnership with NetInspect. So if your OEMs want you to upload results to NetInspect, we have a button right here that will do that. Okay, let's turn the charts off. And the last thing I want to show you is our revision control. So I'm going to go back into the folder where I got my original QIF from. Now I have a revision saved in it. Now this revision was created from the original CAD software. I did that outside of the demo and I put it in here. So I'm going to drag and drop this over, close that. And so now I have the Rev A version opened. You'll notice it looks very similar. There are a few changes, and I want you to take note of this triangle. This triangle, the delta symbol, designates that there is a difference in this particular characteristic. So if I hover over it, you'll see the type of difference that's been changed. So in this case, it's the number of decimal places in the geometric tolerance value. If I scroll down, I can see a few more. The differences on this one are the min and max value have changed. Same thing with this one. Scroll down a little further. Now these plus signs mean that this is a brand new characteristic. It did not previously exist. It's not going to show me anything if I hover over it because there's nothing previous for it to compare it to. The last thing I want to show you about revision control, up here next to the Bill of Characteristics tab is this Information tab. If I click on this, it will show that I just opened this file, and it will show me that balloons 33 and 12 have been deleted. So those characteristics are now gone from this part, and from now on we will be moving forward without those balloon numbers. Okay, that concludes our demo. Now back to the presentation.
Thanks, Shannon, for that demo. And with that, we'd love to hear from you. You can get in touch with us via our website or the QR code on your screen, and we'd be happy to discuss this in more depth and how we can apply it to your specific context and your specific needs. We can go deeper on some of these demos with you, and we can even offer a trial license so you can see for yourself how straightforward these MBD workflows based on QIF really are.
All right, thank you, Shannon and Alex. We're going to move to the Q&A portion of the webinar. I did see a few that said, will this be recorded and sent out after the presentation? The answer is yes. Okay, let's look at the first question here. Is there a free QIF MBD viewer with which the file and the associated PMI can be checked?
I can take that one. As Shannon showed, the best way to view a QIF file from MBDVidia without a license to a particular software is to use that 3D HTML export. So that's an HTML5 based interactive visualization. Like Shannon showed, it has all of the geometry with the semantic PMI. It has the complete bill of characteristics that you've exported with it in an easily readable format, and that resulting 3D HTML file gives the user full interactivity without requiring a license to CAD software, to MBDVidia, or anything else. So you can explore all of that data, dimensions, tolerances, annotations. They're fully preserved and supported. If you select a PMI entity in there in the BOC, the corresponding feature on the 3D model is automatically highlighted. And that kind of continues that intuitive navigation and that clear traceability between the model and the defined manufacturing requirements. So we've seen this and recommended this as an effective way to share MBD across engineering, manufacturing, quality teams, purchasing as well, ensuring accessibility and understanding even for users that it doesn't make sense to have direct CAD access to the native files. And I think part of a question that came in we can address, this 3D HTML file is saved and opened locally. So even though you're just using any browser to open it, you don't need internet access to do so. Another benefit of that 3D HTML export that we provide.
Okay, next question here. Shannon, I think this probably would be for you. Is there a way to change the yellow-red indicator values? I noticed the red example showed red when it was at the max, but not over.
Yes, so in the settings, you can change how tight you want that green section to be. So I think I had it set around like it's by percentage, how far it is from nominal. I think I had it set around like 75%. So most of that um, intolerant space would be considered green. If I made that percentage smaller, like 25%, that would increase the yellow area. So some of our customers who really want to maintain tight tolerances will adjust those values to make the yellow area larger. As for the red area, on the thermometer in the visual area, you'll see it stop exactly at the out of spec limit, but it will highlight in the bill of characteristics anything over that limit. We've just chosen for visualization sake not to make that red area extend past that limit.
Okay. Next one. What are, what are the benefits of QIF? The hardware requirements, software requirements. Who generates the QIF? The customer or us?
I can do that one. So our main point is that there are significant benefits for everybody involved using QIF and using it to adopt model-based definition standards and concepts. So as a supplier, hopefully what we demonstrated is that your workflow becomes much simpler and much more efficient. You're no longer having to have multiple interpretation steps, moving from a 2D drawing to a manually ballooned PMI or manually transcribing that bill of characteristics for your first article inspections. All of this information is already included with the QIF file or can be generated automatically using MBDVidia. Obviously, some considerable time savings there, and some of the less obvious time savings come from the error reduction in not having to chase down transcription errors or interpretation errors. And that increases your overall productivity and of both your quality and your engineering teams. On the OEM side, implementing MBD and QIF standards helps shorten project lead times, partially by maintaining that visibility and control over supplier activities. Because you know the file that your supplier is working from, you provided it, they're providing their information back to you in that same file, in that same format. So standardized digital data, ensuring consistency across design, across manufacturing, and all the way through inspection. Just it eases collaboration, shortens and reduces the number of feedback loops needed, and kind of improves overall product quality. Software requirements, a MBDVidia or something of its ilk in order to interact with the QIF file. And then hardware requirements kind of tie more with software requirements, but especially if you're using CMMs for inspection, being able to take advantage of most modern CMM softwares have some ability and constantly improving ability to directly import the QIF file, access this information directly without that human layer involved, and then export QIF results that can be brought back to the QIF MBD file.
Okay, next question. How many parts can be stored in a single QIF file? Is it a single part, a lot of parts, or thousands on thousands made to that revision?
Okay, yeah, I've got that one. So QIF files can be used for individual parts. They can also be used for assemblies. So with individual parts, you're going to see all of those characteristics be things like dimensions or GD&T. But in an assembly file, you can also have checks for if a part, if a subassembly part is there or not. So it can be used in both, and we do have customers who use QIF files to hold very large assemblies. And then when you generate the inspection report, part of the checks that you're doing are making sure that all of those parts make it into the finished assembly.
Is MBDVidia or Capvidia software in general authorized for use in secure environments? What kind of data security tools do I need to have in place?
Yeah, this is a good question and one that we get a lot given the kind of the drive from especially defense and aerospace industries towards these MBD workflows. So main point here is that MBDVidia is not a cloud-based application and does not store or track information outside of the computer on which it is installed. The software is installed and administered locally. It accesses files on your computers or your networks. And so that means that you can use it in the vacuum of a closed network without any limitations on its capabilities or additional security concerns other than those that you've already addressed in order to use other tools within your environment.
Is the associativity maintained within the original CAD model when model geometry changes?
Okay, so that once a QIF file is created, it does not maintain an active link to the original model that you created. So if you make changes in that original model, it's not going to automatically update the QIF model, and that's very intentional. So a QIF model, consider that akin to a drawing release. Once it's made, that you want that to be a set document that you can reference and it's going to stay the same. We do have plugins for various CAD platforms. So right now it's SolidWorks, Creo, and NX. When you generate you can use those to generate QIF files from your native CAD environment, and that will track the changes. So that ties into another question I saw. How does it know in revision control what changed? With our plugins, it will keep tabs between QIF exports, what changed, and it will make note of what those changes are. And when you export as a revision, it will create those notes for you.
Okay, see some CMM questions here, so I'll try to combine two into one here. How do I actually use QIF to automate CMM programming, and MBD only interact with CMM, or are there more measurement devices that can do? Sorry for that, I'm just reading the questions.
I think I got where those are going. So addressing the first part, CMM programming can be streamlined, and a large portion of it can be automated using CMM software that supports QIF. QIF files bring with them both the features and the characteristics along with the model geometry. So you may be used to importing STEP or importing native CAD files that just bring the geometry, or in some cases some of the PMI, but not the kind of the gamut of features, characteristics, and PMI that QIF provides in a standard way. So that can be most major CMM software vendors today provide some support for importing QIF that can directly read and populate that feature and characteristic information. Then in some more mature environments that use QIF workflows for inspection, quality engineers can, within the QIF, also specify point sampling rules based on, for example, feature sizes, tolerances, or other criteria like that. And that's done directly in the QIF file and can be consumed by an ever-growing number of CMM software vendors, which is really getting us an important step closer to truly automated measurement programming. So it's QIF brings that next step of, along with the traceability of UUIDs, you have the features, you have the characteristics. They are traceable and read in directly by the CMM software. So worst case, you're just providing your probing strategy, and then as use of QIF matures in these workflows, that probing strategy can even be kind of previously defined based on whatever your internal standards or rules are. And then addressing whether it can only interact with CMM or more measurement devices, it's primarily limited to the software. So for example, a lot of the focus has been on CMMs. It's kind of what industry knows, what industry trusts, but other softwares like Polyworks, or I know Zeiss and Hexagon have also versions of their inspection softwares that can support generic point clouds, anything like that, for 3D scanners. So if the software can read in the QIF and can write results to the QIF, or write QIF results, then we can bring those back to the QIF MBD model.
Okay, very good. Let's see here. Not much of a question, more of a statement. Considering QIF for TDP.
Sure, I can take that. Yeah, we recommend including QIF, especially to OEMs, including QIF as part of the TDP, or the technical data package, for its benefits with interoperability and traceability through an entire product lifecycle. So because you're not just getting the geometry and the PMI, the GD&T data, QIF can also act as that container to include supporting documentation, such as reports, setup sheets, and inspection plans. With MBDVidia, we're able to directly attach to the original QIF file, providing a single standardized package to simplify that data management, with those included external specifications that can be themselves, have balloons added to them, have characteristics associated to them, and all of that is maintained directly with the QIF file. So an OEM can define their design requirements, send that to a supplier with the TDP, with QIF in the TDP. The supplier can show compliance to those design requirements, as well as any external supporting documentation, parts, material, processes as well. So QIF was essentially built to centralize, standardize, and trace all of this information in a single place. So it's kind of it is the answer to that question, is yes, QIF was designed to do exactly what a TDP demands.
Okay. Is it possible to compare native format and QIF and MBDVidia, or do I need Capvidia module for this file format comparison?
Yeah, so I can get that. So for those of you who don't know, Capvidia is another one of our tools. It allows comparison of the geometry within various file types. It also allows comparison of the product manufacturing information you saw within the QIF files and step files. MBDVidia does not do that comparison, so that functionality is exclusively within Capvidia, and that's something, if you want more information about later, we can give you that outside of this demo or outside of this webinar.
Okay. Next one is, how should limited dimension drawing undimensioned features be handled in MBD?
It's a good question, because I feel like there's never really a good answer to this, regardless, and it's not really dependent on MBD. So essentially, you can handle limited dimension drawings models or undimensioned features in the same way that they're handled now. Is typically there's an unless otherwise specified tolerance in a note. That note is automatically captured in MBDVidia in the QIF file. So however you report on it now, you can continue reporting on it in the same way. It's just the same note in the 3D model as opposed to on the face of a drawing.
Okay, very good. Let's see here. Does generating QIF from other programs like SolidWorks or Creo support those programs' 2D drawings or only their respective 3D PMI data?
Okay, so MBDVidia does process 2D drawings. It does not process the native 2D files from the CAD software package. It looks at the PDF and converts that to a QIF. In the case it's working with a PDF, what it uses is something called optical character recognition, or OCR for short, where basically it attempts to look at the drawing like the way a human does, and do the bubbling operations and create the bill of characteristics from the characters that it sees on screen. So basically looking at the pixels the way a human would look at a drawing. It is not quite as accurate as the 3D version, because the 3D QIF files are inherently built in a way that the computer can understand it, whereas a 2D PDF was meant for human readability only. But we've done a lot of optimization on our OCR, and we continue to optimize our OCR based on customer feedback. So that is something that can save an immense amount of time, turning, a several day ballooning operation into maybe an hour or something like that, after you've gone through and done all the checks on it. So it is still a very good time saver, and that also exists within MBDVidia.
Okay, we're running a little low on time, so I guess I'll ask this last question. Is there a is there a CATIA integration for MBDVidia QIF export planned? And if yes, when is it going to be released?
So we have a little, oh, you okay?
Go ahead,
we have a little bit of CATIA integration right now. We are working on expanding that, including getting a plugin specific to CATIA that is in the works. We're hoping it will be released relatively soon, but I can't give you an exact date on it. Alex, do you have any more details you want to share about that?
Yeah, I was gonna say we're actively working on it. We feel the need for it, and the good thing is that today we do, through a kind of internal translator, have the ability to load CATIA files directly into MBDVidia. We're just still working on the functionality to export QIF from a plugin within CATIA. So the workflow's still there. It's well supported. We just don't quite have the level of control over the translation that that everybody's come to expect from us, from NX and from CATIA and from SolidWorks. So we definitely see the need, and it's an active work item for us.
Okay, thank you very much. We received a lot of questions, and we wish we could answer them all. However, don't worry, we will follow up with an email answering all your questions. An extremely valuable resource for any supplier getting to MBD is CCAT, or Connecticut Center for Advanced Technology. We've partnered with them for suppliers and OEMs to get technical hands-on training on all things digital thread and MBD. It's a very highly recommended and much needed program to train and upskill the workforce. That's all the time we have for today's webinar. Please reach out to us if you need more information or have questions. Scan the QR code on the slide deck or go to capvidia.com. Thank you, Shannon and Alex, for their time, and thank you to the audience for your questions and attention. Our main message to everyone in the manufacturing industry: suppliers wins, OEMs win when we all get MBD ready. Thank you very much and have a great day.